Hello, everyone. Thank you so much for coming out tonight. Today, we'll learn about building a chatbot with LLMs. But first things first, we'll go over the conceptual understanding of how LLMs work behind the scenes, and then we'll jump into the actual code part so you can actually build your own chatbot with an LLM. But let's start with the basics. What exactly is a chatbot? It's at its core, a chatbot is just a system that communicates with humans, and it's great for us. It helps us solve a lot of our problems like troubleshooting, answering questions, or assisting us with tasks in our daily lives. And it does this by mainly trying to understand exactly what we're asking, that context behind it, and then it builds the context behind the answer and actually answers the question itself. And recently, it's been sort of at its peak because of the concept of deep learning, the idea that you can keep learning from the interactions, both from the user side and the data that it generates. So this is the sort of evolution behind AI chatbots, because they didn't always used to be like this. Initially, it started off as sort of like a rule-based system where it operated from like keywords, like you say something, the user says something, and then it maps it to a specific answer that it replied. But it sort of became very like monotone. The answers are usually always the same, and there's no consideration for further depth. But things kicked up when machine learning came along, because then the idea of predicting the response based on what the user has given started to come along, because now we can map out all the patterns that the user is showing and reply based on those patterns. But these patterns are what we as developers decide, so it's also kind of limiting. That's when deep learning came along, where it's sort of the idea of we already train the model and everything from our side, but it also just continues improving from all the user inputs and all the data that's generated in this process of communicating with the user itself. And previously, there's deep learning techniques like recurrent neural networks and long short-term memory that have been very popular in the past, but recently there's been sort of like all the LLMs that have sort of come on have this underlying architecture for something called transformers. And this is the sort of structure that they are built on. I'll talk through each part of this, but initially, let's say you give the model an input, like what is the capital of France? The first thing it does is actually processing the input so that the model can understand it and understand the context behind what it's being asked. So it breaks it down into like words, and those words are then converted to tokens. Those tokens are what and then it's also important to understand the position of those words itself, because if in the English, the way a sentence is formed is also important. Like let's say you switch two words in a sentence, it's going to mean completely different than if it was the other way around. So it's important to understand the position that it came from as well. So after it does a tokenization from the word itself, it's like I want to remember the position that was in, so I can understand the meaning behind it. And this is the sort of place that it was on. So within the actual model architecture, this section here is where we actually process the input. So you'll see once the user gives the input, it has a tokenization where it has the input embeddings, and then you have the positional encoding to try and understand the concept itself. But now that we have those numerical representations, it moves on to actually understanding the context behind the actual question. So what it does is stores it as a vector embedding into a vector database. And think of vector databases as it's like a lot of nodes just floating into space. And the way that they relate to each other is how they're relevant to each other. Like and there's a mechanism called self-attention that connects those words together and puts those into numbers And once we have that sort of data about how the words connect to each other, we can understand a little bit of context about what's being asked. And now all we have to do is filter out all of the bogus that's being asked before the question itself and just get the underlying what the actual user is asking so that we can process the answer itself. And you'll see that this process of understanding the context behind the question is called encoder, and this is the portion that it's at. These arrows here is the self-attention part of it, where it tries to connect the words and see the relevancy between the words. And then once it has this part done, this is the actual processing layer, where it sort of removes the bogus so that it actually understands the question. And once this encoder part of it is done, then we move on to the actual decoder, where we start thinking about the answer. And the way that the model usually starts doing that is it starts with an SOS, start of sentence, and then it starts essentially generating it based on the encoded question, what we just gave it, and everything that it's generated before it. So it takes those two things into context, and it's like, oh, this word could be next. And all it's doing is just providing context with what could be the answer so far. And again, after that's done, it just removes the sort of underlying answer from that through the processing layers and passes it on so we can actually put that response into like a human formatted language that we can understand. So you'll see that this is the actual decoder part of it. This arrow that's coming out of the encoder that we just talked about is coming into here. And then you'll see there's another arrow coming from this bottom section, which is like what has been previously generated. So both of those ideas to now go ahead and do word generation and pass that along so we can do filter out the actual relevant information. And this entire process is called a decoder. Now, once we have all of the context behind the answer, now let's start forming the answer. So we start by the first start of sentence, that token, and then we start lining up words one after another based on a probability distribution. So what we just got was like, think of it like a blob of data, and then it's a probability, and we convert that to a probability distribution. And it's like, what word could possibly come next? It takes the one with the highest probability distribution, and it lines that up as the next word. So this is the sort of the overall how transformers work, all the way from the input to whatever the word is being generated or what response you're getting. And most primary examples that do this is the BERT model or ChatGPT model. And it basically, the way it uses it, it just uses this model architecture, this idea, and then it trains. And the way that it trains is two ways. One is this masking technique where it has this idea of a missing word in a sentence, and it has to predict what word could possibly go there. Or it has this idea of what the next word in a sentence could be. So it uses both of these techniques to train the model so that it's now able to become sort of like better or more conversational. But the problem is that this is very computationally heavy. It takes a lot of resources, it takes a lot of time. And time keeps moving along, that sometimes these data sets get old. So we have this idea of RAG, retrieval augmented generation, where it basically just instead of like training the model continuously to get it up to date, it's taking external knowledge and then it's feeding that to the model before it even generates. So it's like, hey, this is the question, but this is the context we have. I want you to look at both. I want you to like files, but we basically extract the text from these files. We do the input generation that we initially talked about, how we put them into vector embeddings, and then there's like tokens that are stored in vector databases. But the reason why they're stored in vector databases in the first place is because it's so much easier to search, and that idea of relevancy, the fact that they're close to each other, so we can just find relationships together and put that in the actual answer context. And now once it has this idea or the context behind it, now it's time to actually when the user asks the question, now it can retrieve whatever context behind it is, then go into the actual, put that in the actual prompt along with the question, feed that into the LLM, and then give the answer. And the most common application of this entire RAG process is like Notebook LLM. It's been coming on pretty great because in Notebook LLM, you feed your own papers. So you don't like see the process, but you get the idea, that initial underlying idea is what Notebook LLM is built on. And then recently, ChatGPT also got this idea of web search, where it does an internet search about whatever question that you ask it. So it gets that context from like 2025 instead of some of the databases that store like 2021 knowledge. And then before we sort of jump into creating this entire process, I want to briefly talk about NLP and natural language processing. So we talked about transformer models. We talked about how they're used to take user input and generate a response. But, you know, sometimes it's not always necessary that we want to converse with the user. Yes, text generation is great, but sometimes we just want to know what the user is thinking or extract a lot of knowledge from the user input itself. So that idea is called natural language processing. And just to roll along with the text generation ideas, instead of just the chatbot idea where you converse with the bot, there's also other types of text generation where you can translate from one language to another, or you give it this huge blob of text and you're like, summarize this. So it's taking that, analyzing that, and then it's summarizing it into a shorter length text. And then, like I said, it's not always text generation. So there's an example of that would be like sentiment analysis, where you sort of give it, let's say like a poem. It like reads the poem and it's like, this is the emotion behind it. So I'm going to do something with that information in the future, like grab a piece of music that's like sad or a poem that is sad. So it can be sort of used in that context as well. So now that we have a basic idea of all of these concepts, let's redefine our definition of chatbot. We previously said that AI chatbots are just like a system to communicate with users, but now we know that it uses the power of NLP, RAG, and transformer models behind the scenes to try and make that experience for the user by making it more accurate and more conceptually accurate and just adapting to the user needs. And then, yeah, this is sort of putting it all together. So initially, the idea of determining what the user wants, that input processing layer that we initially saw, is an example of NLP. We put that into a transformer model. And I know like I dumbed it down, but transformers essentially just understand the context behind it. And before we actually do the generation part of it, we put it through RAG so we can get the most up-to-date information from external sources and then pass that along for actually building a human-like response. And that building a human-like response is also like an example. And initially, I started with the idea of deep learning because it's the idea that you can adapt, you can keep learning. So throughout this entire process, this process repeats and the model keeps learning and improving from this entire process. And yeah, this is sort of like an overview of what we discussed. We talked about transformers, how it uses self-attention to get sort of the context behind what the user has asked, and then build on the answer that it is. We have RAG, which basically just takes external knowledge and integrate that into the actual prompt so it can now generate up-to-date information. We have NLP, which is, we talked about text generation examples, and we talked about how it doesn't always need to be text generation. We want to sometimes analyze it using machine learning techniques or AI. And then finally, we put all of that together to redefine what a chatbot is. And yeah, that's sort of the conceptual understanding of it. Do we have any questions? Perfect.
I think one day. I was going to say, you mind turning on the microphone?
Oh yeah.
Or maybe putting a little closer.
Sorry.
No, thank you.
It's like my first time using this. Yeah, thank you so much.
Thank you.
If we don't, I think, if we don't, let's get food and then we can come back to do the coding.
That's how it's There's usually like a better. No, I didn't realize you had a lot.
I think they.
No, keep it on.
Keep it on, but like,
Oh, you can turn it off, but you can keep it on. That's not like we're using.
I do think of a question. Like these slides, are they gonna be provided somewhere?
Yes. Yeah, they'll be provided on our Discord and we're gonna provide them to the Night Hags Discord.
Okay. How can I get more information about that? Because I did like there was some. Yeah, and I'm definitely very interested.
Yeah, so we can talk with you afterwards
Yeah.
about our club. We do have our Discord server, which you can go to at ucfai.org/discord.
Yeah, I'll get that.
Yeah.
Okay, thank
You can also ask.
Yeah.
Oh, I'm speaking, but I just want to say, I can't badly. Sorry about that. Happy that we got to collab because I just.
Hey, congratulations. This is going to be some of the most work you're ever going to do in your entire life.
I don't. It does. Does it mic work?
yeah.
Yeah, I think you have to turn it on.
Okay. I think she's good. That's why they're supposed to have. Okay. You're doing a good job, though. Thank you. What's the difference?
This is the collab that you do before, so you can do it on your phone. It's like a.
So I'm trying which you have in this data. Yeah, nothing on a part. The desktop screen sharing friends. Display. Duplicate. Deep.
Thank you. So maybe we can get started. I have a QR code here that will take you to the Google Class. Okay, guys. I can't. Hey guys, we'll get started with the next part here. With the coding session, we can feel free to grab more as we go. But we'll sort of demo at the top here. But this is the collab that we'll be putting where there's at the bottom. You can pull that up on your side. You'll see the plot that's like very thorough with step-by-step instructions on how to do things. But I'll be demoing others so you can follow along or do it on your phone. And if you need help, you can always just raise your hand. Initially, when you come on to the actual Google Lab, this is sort of what it will look like. You want to make a copy of it. and edit that part here. I'll just remove the copy of here. But you'll see that there's two main parts of it. Part one is building your chatbot with Google Gemini, and then part two is using a pre-trained model where it isn't that AI service, you're genuinely dealing with the actual model from Hugging Face directly, and that's how a lot of models are fine-tuned and trained further. But this part, first part, is like if you want to build like a custom chatbot for yourself for a website or a business that you lead, this first part would be that. But yeah, first things first, we want to get the API keys to actually connect to the Google Gemini LLM. So if you go to this link here for Google AI Studio, you'll see this, and then you can get your API key here. Just create a new API key. In this case, we use the Gemini API. I think for me it's a little bit different because I have this already, but it will probably give you the name that you want to make it, but you want to make it like something like Gemini API for something like that, and then your API key will be here. So you'll just copy that over, and normally it's not recommended that you store the API code in the code itself. So we're going to store it as a secret, which you just select new secret. We're going to say Google. Your actual API key in the value tab. But once you just like come down a little bit, you'll see the section here where it shows you how you can access this part here. So if you just copy over that, and then this part will be the actual name that you gave it. So in this case, I put it as Google API key, and we're going to store it in something, in a variable. And then just to make sure we don't have any errors that we probably do. Okay, perfect. So once we have our API key sort of initialized, it's time to configure that API key. So we'll start by importing the libraries. I'm just following along as it says, so you can continue to do that as well on your side. But we're going to import the Google Gen AI API from Google, import Gen, and actually configure the key. So if I say client is equal to once we have that configured, then we can actually connect to the model itself. So we'll say model ID is equal to, in this case, we're going to use Gemini 1.5 Flash. This is the free model, so it won't like charge you, because a lot of models like OpenAI to access ChatGPT, it's going to charge you unless you pay for that initial $5 fee. Usually they had it like free, had free credits previously, but they just updated their terms and conditions, and now you can no longer do that. But Gemini is free for the most part, so we're going to use that for this workshop. But once you have your model, it's time to initialize a chat session with the model that's specified. So we're going to say chat is equal to client.chats.create, and it's just going to be model equals model. Now, once we do the initialization, this is the part where the customization comes. Yeah, go for it. Yeah. can help you there. But once you initialize the model itself, now you can actually use it. But before we use it, let's customize it a little bit. We can say, let's something called a system prompt, where you can say how the chatbot behaves. So anybody have any preference on how we want this to behave? No? Okay. This is going to be our system prompt. We're going to risk the user no matter what they say. I'm not sure if it even knows what risk is, so we'll see. But we did the system prompt. Now it's time to send it to the actual model so the model knows how to behave. So we're going to do chat.send message system prompt. And you'll see this giant blob. You don't really need to deal with this now, but just to show you, there's this text section. Oh, there we go. There's the response. Let me get a better prompt going. This is from GPT. So usually you can GPT your system prompt. That's the only part that I recommend actually GPTing, because that part is pretty thorough. So okay. Yeah, go for it. Oh, step 1 was just getting the API key. Step 2 was configuring the API key, and now we're actually going to the models. I think this is the one issue. Okay. Let's see if that works. Oh, there we go. Text. Hello there with delicious. Okay. It'll work. But this text section is usually how we get the response from the text. Yeah.
Can you put the link into it?
Yeah. Here you go. No worries, you're good. Perfect. Now we have a system prompt. We customize the chatbot to act exactly like we want it to be. And now it's time to actually get that conversation factor where you enter the input, the bot generates something, it's time for you to get another input again. So we'll do a loop here where we get the user input. And then if the user ever ends up typing exit, you can tell how many times I did this. It's already giving me suggestions. Okay, if the user presses exit, we're going to break. Otherwise, we're going to send the message to the LLM, and then we'll see the response in writing here. And then this is a while loop, so we'll keep going again and again, and we'll ask you for your response. So we can actually test that out here. So if I say something like, hi, chat, the last message. Oh, I forgot to store it. Okay. Here it did like a chat.send message, and we got this huge blob. We just want to store that blob so we can access the actual text part of it. Oh, sorry. We got a response. Let's do it twice just to make sure that it does work. Okay, perfect. And we just exit. To start, you have a model that acts exactly like you want it. You can have a conversation and continue having this conversation with them. But we'll move on to handling other types of inputs. So a model, you don't always deal with just text. You want to deal with sometimes images, so it can like take that image into context or like another document, for example, so you can process that and ask it questions about it. So in this case, we'll just handle images to see if it can maybe recognize like a picture of a cat or a picture of like a dog. So first things first, we will import hello dot image and then yeah, and then we'll import the file. So this is for processing the image. This is for uploading the actual file and processing that even more. Also, let me know if you want me to slow down, but I know I'm going like really fast. But now that we have the libraries, now we can actually upload or create that system where they can upload the document. So we're going to say that load image. There we go. Okay. Wow. That's our override. But basically the way this works is the first line just creates that portal for you to upload the file, and then it stores that into this thing called uploaded file variable. And now you get it whenever this variable is sort of like a list in this case, and 0 is the file name. And we take the or file name or file path sometimes whenever you upload it from your computer. But this part here, all it does is just opens the file and just returns it to you. So you are now ready to process. Now we just edit this part here, so now it can handle images. So if I say something like, now this input is equal upload, then we want to actually run this and store whatever the result is. So we can feed that now into the actual things. Image is equal to load image. We've had this previously where we have asked the user input. If they say exit, we break out of the loop, stop asking them anything. If they say upload, then we run this here where we get the input and then upload the file and then send it to the response. And then this part here is going to continue doing it if they don't choose to upload it. Let's run that and just double check if it works. Before we do that, let's find a picture of a cat. Let's try uploading. Oh, Load image not defined. Oh. Now we choose a file, like chat. Mm. There might be a format issue. Oh, no. My bad. Oh, give me 1 second. So it generates this response and it knows that it's a cat and we're feeding it. And yeah, that's pretty much how the upload feature works. If you want to keep chatting with it normal, you can do that, or you can keep uploading an image. And instead of doing this process where you have to put it as like a prompt, a part of the prompting, you can just, if you have your own UI, this is the part where you would have a button that automatically prompts you to upload your own file instead. But for simplicity, this is just to show you how it works. But so far we got the chat generation, the text generation, and the image processing. And now it's time to jump into the actual RAG part of it. So brief overview, RAG is just taking the external knowledge that it has and feeding that into the model so it can now take that information and give that to you. Now, our initial prompt was RIS, so we can make it like relevant to that itself, or we can make like a RIS Academy and say that it was founded in like 2000. It's not a real thing, but so let's see like if it actually understands that itself. So we'll start by just getting the proper libraries in and importing this part. For this example, we're going to be using a pre-trained model of this. So normally whenever you have a situation with RAG, you have to choose an embedding model. Whenever you choose like, because we're going to replicate that entire cycle of you're given this document, you have to process that, you have to store that in your vector database. So we're going to store it in the vector database, you need that embedding so that you can store it. So in this case, we're going to be using the pre-trained model All-Mini LM, but you can use the most popular ones like OpenAI has an embedding model for text. There's also like BERT ones that have the text embedding models, and there's a lot of ones that you can probably find if you go to Hugging Face. But in this case, since this is like very small scale and can operate on Collab, this is what we're going to be using for this example. Let's finish it loading. But so far, does anybody have any questions or any part that they want me to explain. But while this loads, let me show you Hugging Face that I keep talking about. So Hugging Face is basically where all the models are uploaded. So any model that you create goes on here, and usually, like there's like AI news where they have like rankings, like, oh, this model is the top model that just got released. This is usually where they showcase those models. So if you like search a model that you want, like image generation, it will usually give you something like relevant. Probably not using it right. But you'll see like there's DeepSeek and you can use it from here. So if you like click on something like this, click use the model, there's the transformers library that you can use it to. And this is actually what the second part of this is about. This part here. This is going to be using something like this, a model on Hugging Face, to get a chatbot working from there. Just to demo that it's possible and the fact that you can do a lot more things with it. But okay, perfect. This loaded, and now it's time to actually create the vector embedding. So we'll start with making the documents. Like we said, the Riz Academy, it was founded in like 2000. So we'll do docs. Just as an off note, I can probably say like, my name is Tom. Just to see, because so far in any of the conversation, we haven't shown our name yet. So this will be sort of the signifier in case, just in case there is a Riz Academy. Now, once we have these documents, now we can convert it to the embedding that I talked about. So we can now store that in our vector database. So we'll do embeddings. This probably needs to go in a loop. I think we might need to process that a little bit before we get into the next part of it, but let's define our main vector database. We'll use phase index as a main basis for doing the entire vector database process. So that, I'm not really sure if that should work, but let's try it. Probably doesn't. think we might need to reshape this before we go into, oh yeah. Normally when you do the encode, it usually comes off as another data structure that you access with dot shape. But just to convert it to something that we can process with, in this case, we will do the np.array, so we can convert that to a numpy array. Okay, perfect. Okay, so far we got our documents. They're now in the embedded form. We have our vector database that we added the embeddings to. And now it's time to focus on the user queries that we could get. So whenever we get user queries, we want to process all of this retrieval stuff in a function. So we can write a retrieve function. Give me 1 second. So once we get the user query, what the user has asked, we convert it to a vector embedding itself. So we can now compare it to other vectors in the database, and we can find the relevancy to that. But I think I got this error when I was initially coding it up. But we have to shape it to just like a flat one thing of array so that it can actually get that data in a single form of like string or access for a single index. And then we actually do the search itself. So you have the query, we encoded the query so we can now search the vector embedding. And now this is the part that actually searches in our actual vector database so that we can store that and now access that. So this part will be the sort of indicator or position about where exactly that data was that we're trying to retrieve or what the user's asking about. And yeah, the last part would just be the actual how to communicate with the user. So I'll just copy this down here. And we'll just make edits to this here. I removed the image for simplicity, but the only thing that really changes is right before you actually send the message over, you want to now retrieve the relevant knowledge that goes into it. So I will say get retrieve. I think I called it retrieve. Is equal to retrieve and the user input. I'll format the input that we feed to the model so that we not only have the user input, but also the context behind it. So if I say run everything else. Already starts out with Tom, so we know it worked. But let's just ask, when was Riz Academy founded? Did we specify 2000? Let me check again. Yeah, we did. Oh, 2000. Okay, perfect. Okay. But yeah, that's pretty much how it works. So far, we built the actual chatbot. We customized it to whatever we want. So in this case, I did it for Riz, but you can do whatever you want for your website or for like a business that you're running. We added the idea of image processing and how we determine that the model is accurately able to detect that image and process that even further. And then we talked about RAG. So in this case, RAG is mostly based like text-based. I know like I showed the array part of it here, but normally it's not always going to be the simple. You like say you want to put like a PDF in. So usually you start with, I want to get the PDF. I want to extract all the text, and then I will put it in a format like this, and then feed that into the actual model. But yeah, I think that is it for at least part one. For you to like edit it as you want. If you want to build a feature where it takes in an like input as a PDF, processes that, or like scrapes the web page that you put it. You can also just do that, or you can have like a database like a Wikipedia. You can pull that up, see if you can hook that up and see if it gets that data and generates accurate information. But other than that, I think that's it for part one. I'll just introduce part two briefly, but I don't think we'll go too much into it since it's not as relevant. But basically, you do very similar things. You import the actual model tokenizer and the model about what exactly you're going to be working with. Then you define your system prompt about how you want it to act and build that interaction feature. But you have to be a little bit more specific because in the LLM, all of that is built for you. Like you have the conversation history, it's able to remember what you just talked about and bring that up into conversation right now. But that's not always the case for some of these models that aren't trained for it. So you might have to get like conversation history. I think this is probably what it talks about here. You want to have a conversation history, the system prompt about what you want the model to do, and the actual user question about what they're asking. Combine all of that, give that to the model, it generates a response, and that's what you give back to the user. And this is to get that back and forth from the user. I enter something, the bot responds. I enter something, the bot responds. And you can also integrate RAG as well if you want. And yeah, that's pretty much it for the coding part of it, unless anybody has any questions.
Does anyone need her to go back to any part of the code?
Sorry.
Double check if you have any errors. Could you go back to 4?
Before? Oh, 4? Yeah. Which part of 4?
Which one?
But if that's all, you can always just stay behind. I think we'll help you through it. If you want to do this all yourself and you don't actually follow along. And then the second part of it, you can also just stay behind and work on that and help you through it. But other than that, thank you